What is up, mathletes? Welcome back to another episode of Math with Dr. Math, and today we're going to talk about solving basic inequalities. Have you heard about them? All right, folks, so let's jump in this. Let's talk about solving these basic inequalities. All right, and then later on, you could check out our other videos that get a little bit more involved, and we start talking about compound inequalities and absolute value inequalities, and we get more advanced. But today, let's make sure we have that foundation. All right, so what you're going to notice when you're solving these is that the process is very similar to the process of when you're solving equations. All right, there's only a few differences. Okay, so whatever you could do with equations, pretty much when you're solving equations, you could pretty much do with inequalities, except with equations, we usually end up with either no solution, one solution, two solutions, depending on the degree of the equation. There's not too many possible solutions, right? Unless you're dealing with these humongous degrees, but usually we don't deal with huge degrees. Here, what we're going to notice is that you're going to see a lot of solutions, and because of this, we need to attack this a little different. Let's dive in. So here's our first example. So what I tell my students is pretend this is an equal sign. So if you were solving for x, what would you do if this were equal sign? Same thing holds true here. So what we're going to do is we're going to move this 3 to the other side. All right, here's a pro tip for you. You could listen or you could not, it's up to you. All right, I always like having my x on the left hand side, all right, especially if my wife is with me. I'm just kidding. So your x variable, always have it on the left hand side. You're gonna find out right now why. All right, so check this out. We're gonna go ahead and subtract 3 from both sides. All right, so we end up with x is greater than -1. So x is greater than -1. So listen to what we're trying to do, because the solving part is easy. The understanding part, that's something else. So what are we looking for? You're trying to give me all the x values that when you plug this in, right, is gonna make this statement true. I want this side, my left-hand side, to always be greater than my right-hand side. What numbers can I plug in that would make this true? Well, you're gonna see, well, if I plug in 0, that gives me 3, that's bigger than 2, so 0 works. If I plug in 1, well, that's gonna work. If I plug in 2, that's gonna work. So there's infinitely many solutions, right? There's too many for me just to list. So what we do is, this is why we need an inequality to represent all the numbers that work. So as long as x is greater than -1, all those numbers will make this statement true. So you might be asked to write your answer like this, or you might be asked to write it in a number line. So let's say we have this number line here, and I'm looking at 0 is right here, and -1 is somewhere over here. And so notice, x is strictly greater than -1. So in some textbooks, what you're gonna see is an open circle and shade everything to the right. In other textbooks, instead of having an open circle, you're gonna have a closed bracket here that looks, a parenthesis, right? Because it's not included, and then you're gonna have the arrow going to the right, right? They mean the same thing, it's just different notation, right? You might be asked to write this in interval notation. So we're saying that x represents all the numbers that are greater than -1. So we start at -1, and we go all the way to positive infinity. This is called interval notation. And some of you might be asked to write it in set builder notation. And the game plan the blueprint I like giving my students is, check out what your variable is. So if your variable is x, this is gonna be our standard blueprint. All right, so just remember that notation. And then what we do is we grab our solution here and we stick it right there. So just to show you, I grab this and I put it right there. And all that means is, well, what's the variable we're working with? It's x, right? That's the variable we're solving for. And what can x how can we represent x? Well, x is represented by all the numbers that are greater than -1. All right, so again, what you're gonna see is that the solving part, right, is gonna be very easy because it's similar to solving equations. Let's do another example. All right, this one's a little bit more involved, and if you listened to my pro tip earlier, you would already know you better like this video, subscribe, right? And we need to keep x here on the left-hand side. So let's go ahead and let's move all our x's to the left. So we're going to go ahead and move all our x's to the left. So we go ahead and combine like terms. We're left with 1x plus 6 is greater than 7. Some of you are going to want to do multiple things at a time, and that's great. I just tell my students, let's do one at a time to make sure it's easy to make little mistakes, right? So I just focus on one thing at a time. All right, so now we're solving for x. Let's move that 6 over to the other side. It's -6 minus 6. So now we see that x is strictly greater than 1. So here, if I'm doing my number line, I got 0 somewhere, 1 right here, and again we have an open circle or a parenthesis depending on your textbook, and you're shading everything to the right hand side. All right, any questions? Good, because I don't have time to answer them. All right, let's do another one here. Well, what happens, Dr. Math, if I decide to put the x on the right hand side? Get out! It doesn't matter, right? It doesn't matter. Let's go ahead. Let me just show you what would happen. All right, and this is where we have to be comfortable with the language. So let's say I move the x's to the left-hand side. All right, so let's do that. No real difference except I'm going to point something out in a few minutes. So we're left with -5 is less than or equal to 3 minus 4x. All right, let's go ahead and subtract 3 from both sides. Subtract 3 from both sides. And you're left with -8 is less than or equal to -4x. Remember what we're trying to do? We're trying to isolate the x variable. So let me go ahead and divide by -4. This is where you're going to make a very important note, right? In your notebook there. When you divide or multiply by a negative, you have to change the direction of this inequality. So instead of being less than or equal to, now we're going to see that that inequality is going to say greater than or equal to. Write that down, right? Very important. So over here we get 2, and over here we're now left with x. All right, so what I tell my students is we could leave it like this, but I prefer to have the x on the left hand side, and we'll see why. So I'm going to rewrite this as x, and remember what we said earlier, 2 is greater than or equal to x. So that means that x must be less than or equal to 2, right? Those two statements, they mean the exact same thing. So whenever we swap these, this variable and this number, right, make sure you change the direction of that inequality so that it says the same thing. All right. Why did I even do that? Well, let's pretend that I don't have this right here. All right. When I'm graphing this, when I'm looking at my graph on the number line, we're looking at 2. So let me put 2 here, and it's greater than, or sorry, 2 is greater than or equal to x. So I'm gonna have a solid circle because it's equal to 2, and it says 2 is greater than x. So that means x has to be less than. So you have to make sure you understand that logic and read this out loud. 2 is greater than x. So whatever x is, 2 is greater than it. That means x must be any of these numbers over here that are less than or equal to 2. All right. The reason I like this format right here with the x first is, look at this right here, this inequality. It kind of looks like an arrow, and if you notice, when x is on the left hand side, this will always be pointing in the same direction as your solution here. All right, so this will always point in the same direction as this when X is on the left-hand side. Man, I can't be giving you all my secrets, right? So write that down. That's going to be very helpful as you're working on inequalities. All right, folks. So go out, try some on your own. Let us know how this helped you out. Comment down below, subscribe, like, and we'll see you in the next video. Peace.